This week we're going to be talking about work and power, and this is kind of an interesting picture here. This is an old car pulling a plow behind it, and you may have heard of cars having a certain amount of horsepower. And the reason that they use that unit of horsepower to try to define how powerful a car's engine is because back in these days, a lot of people had horses, but not that many people had cars. And one of the ways that they wanted to try to sell these cars was to try to tell them that they could do the work of several horses. And so they used that as kind of a unit. A lot of people understood the basic idea of about how much a horse could pull or how much work it could do or things like that. And so people that were selling their cars wanted to try to tell them that this car can do the work of 10 horses or 20 horses or something like that. Of course, these days we still use that unit, but it doesn't quite mean the same thing to us, but it still is the same amount of power and gives us a sense of how powerful the engine is. These days we have engines with 3,000 horsepower and things like that. So we're going to get into talking about this idea of what we mean by work and what we mean by power. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here.
Hi, my name is Bill Robertson, and you might know me better as Dr. Skateboard. Welcome to Dr. Skateboard's Action Science, a video series that explores the physical science concepts found in skateboarding and BMX. In this video segment, Simple Machines, we will explore what makes up simple machines, what they do, and how they help riders perform tricks both on boards and bikes. So let's get moving and learn about simple machines. What is work, and how do simple machines contribute to the ability of an individual to do work? By definition, work is the amount of force applied to move an object in the direction of a force. Yet work is only accomplished if the object moves. In action sports, when a rider pushes to get up a wall or down a ramp, the push is the force over a given distance, resulting in work performed. A rider uses the slope of a ramp or the curve of a transition to provide an increase in the amount of force in the same direction by pumping down the incline or through the point of transition. In mathematical terms, you can calculate the amount of work by multiplying the force times the distance an object moves. Since work equals force times distance, you can calculate work by multiplying the result of the force by the distance covered by a rider. Complex machines, like skateboards and BMX bikes, which consist of more than one simple machine, can also demonstrate work as well as its relationship to power. When you see a rider going fast, you probably notice that they cover various distances in a short period of time. In other words, the force, distance, and time that they cover while riding relates to their overall power. Power is defined as the rate at which work is done. The less time it takes a rider to accomplish a run, the more power they deliver. Also, the power can increase with more force or greater distance traveled in the same amount of time. Mathematically, power is equal to work divided by time. For example, if a BMX rider has a force of 550 newtons, covers a distance of 10 meters, and does this in 5 seconds, how much power does he generate?
So in that video clip, he talked a little bit about the idea of work and power and how it applies to skateboards and that kind of stuff. So first of all, we've talked about work a little bit already. And remember that the important thing about understanding work is that basically you need to apply force to something, and that thing needs to move in the direction that you are applying the force. So in this case, well, even though this guy seems like he's working really hard over here, you can see some sweat coming down and stuff like that. He's trying to lift up this box, but the box is not moving at all. So he's applying what I would assume is an upward force here, but the box is not moving upwards, so no work is being done in that picture. Well, in this picture over here, you can see that he is applying an upward force with his hands, and the box is moving in an upward direction, so there is being work done on this picture right here. So let's take a look at some of the math behind this and how to actually calculate how much work is being done. So here's your formula: work equals force times distance. So what we're going to do here is we're going to multiply the amount of force that you are applying to the object by the distance that it moves, and that's going to tell us how much work you've done. And I think this kind of makes sense if you think about it logically. Basically, if you have to push something really heavy and you have to push it a really long distance, I think we would all agree that that would require a lot of work in order to do that. So that's kind of the idea. So let's take a look at this picture, and first of all, let's figure out if there actually is a work being done here. So is there a force being applied? Yep, there is a force of 1,750 newtons. And is there movement? Yep, there is movement of 2 meters. And are the force and the movement in the same direction? Well, both of those arrows are pointing up, so it looks like a check mark to me. So let's try to figure this out. So work equals the force times the distance. So we have the force over here. Force is 1,750 newtons, so we'll fill that in. And then we have our distance right there, which is 2 meters. And I'm going to let you guys, you can certainly use a calculator on this, but I'm going to let you guys figure out what the answer is to that problem. All right, here is our little triangle here. So fill in these ideas, and remember that the idea here is that if you are trying to figure out one of these, then you'll do the math problem with the other two. In other words, if you want to try to figure out the amount of work being done, you will do force times distance. If you wanted to figure out the amount of force, you would do work divided by distance. And if you wanted to find out the distance that something traveled, you would do the work divided by the amount of force. That's the way these little triangles work. All right, so I want you guys to take a look at this next clip of two drag racers racing against each other, and then we're going to talk about it afterwards.
Behind Gary. Becomes champion. Unbelievable side-by-side race that was. I mean,
okay, so I think we can all agree that both of those cars are doing work, that the engines are doing work. There is definitely a force being applied, and the cars are moving. So, but one of the cars won and one of the cars lost. So, isn't one of the cars doing, I guess you could say, more of something than the other car? There's got to be something that the winning car did better or did more of than the other car, because they both did a certain amount of work. They both went the same distance, but one of them did it faster. So it seems like the one that did it faster should have done more of something. They probably did more or less the same amount of work in that situation. It's a little hard to tell without knowing all the numbers and stuff like that, but they probably did about the same amount of work there. They both applied a certain force to the car and they both traveled the same distance. So it makes sense that they did about the same amount of work. But it just seems like since one of the cars won and one of the cars lost, that the winning car must have done something better or done more of something. Well, that's when we get into this idea of power. So power basically equals work over time. Work over time. And that actually is our formula, work over time. And so the basic idea here of power is that you do a certain amount of work, but if you do that work faster, that means you have more power. Think of somebody like the weightlifter that we saw in the first problem there. If a weightlifter lifts up a weight and they can lift it up very quickly, that we would say that that person is very powerful, right? If a person can lift up a weight, but it's really hard for them and they can do it, but it takes a really long time and it's very slow, then I think we would all agree that that person would not be as powerful, right? So full of power. So that's kind of the idea of power, is it's how much work you do, but it also includes this idea of the amount of time that it takes you to do that work. So in order to figure out the amount of power, we first have to figure out the amount of work being done, and then we have to divide it by the amount of time that the work is done over. So let's try out a problem with that. So here's a guy who clearly is frustrated from his facial expression there, and he's trying to push this very large box. So, okay, let's give it some numbers here. Let's say he uses a force of 10 newtons, and he moves the box over a distance of 6 meters, and he does this all in about 2 minutes. Okay, so let's figure this out. Well, as I said, it kind of requires us to do two mathematical equations here, two problems. So let's do the first one first. Let's figure out the amount of work that's being done in this situation, and then we can find out how powerful this little guy is. All right, so your formula for work is force times distance. The force is 10 newtons and the distance is 6 meters. So I'll let you do that and figure out what that number is. You shouldn't need a calculator for that. You should be able to do that pretty easily. So then what we're going to do is we're going to take that number and we're going to plug it in over here, right there, into our work number, and we're going to divide that by the 2 minutes. So whatever number you got for your work, you're going to divide that by 2, and that will be your final answer. So go ahead and write that stuff down. This should be a pretty easy math problem. You should be able to do this. And here's one more triangle for us. So the amount of work that's been done equals power times time. And so if we wanted to, we could figure out the amount of time if we and we would do that by dividing work by power, or if we wanted to find the amount of power, we could do work divided by time. So that's the way that works. Now, one more thing before we finish this up here, I did want to talk about the importance of this. So work and power are actually a really important concept that apply to a lot of different fields and a lot of different jobs that you might have or something like that. It's certainly something that's important if you are an auto mechanic or somebody who designs or builds cars. You would definitely want to know about power, the power of the engine and things like that. This would have an effect on how the car accelerates and how the car handles and the efficiency of the car and things like that. A lot of things. So if you are interested in cars at all, that's definitely an important idea for that. It's a very important idea in our military. the work and power of, say, our different machines that we have in the military, like tanks and the different Navy boats that you guys see, the ships that you guys see. Those have a lot to do with work and power, very important part of that. In cranes and construction work and things like that, there's a lot that goes into that. So designing the cranes, but also using the cranes and understanding how much load, how much weight these things can lift up and things like that, whether it's a bulldozer or a crane or things like that. It could even be something like a shovel or a hammer or those kind of things, or a drill. All of those things deal with the idea of work and power, and having an understanding of how much power those things has really can affect what types of things you would use in a certain project, or what types of things you would buy if you needed to do a certain project. Very important idea in that. And last but not least, this is actually a picture over here of some offshore wind turbines. And this is something that has actually been suggested in Virginia. We have a lot of ocean off the coast there that we actually own as Virginians, and we can kind of do stuff with it. And so we could use wind turbines for that. And that's a really important idea there, because we're really going to have to start switching over to renewable sources of energy, regardless of all the types of things as far as pollution or climate change or things like that. The bottom line is that non-renewable resources like coal and oil and things like that are going to run out. That's kind of the definition of what it means to be non-renewable. And they're probably going to start to run out within your lifetime. So you guys are really going to have to know about this kind of stuff. And wind power and hydroelectric, water power, those kind of things really deal a lot with this idea of work and power. It's all about how do we design these windmills, the things like the blades on the windmills and things like that, and all the little gears and stuff that are inside, to get the maximum amount of efficiency out of these, so they work as well as they possibly can. They are using the air, the wind, the water, things like that, as much as they possibly can in the best way possible to get the most out of them. Really, really important concept, and something that you guys are going to be dealing with a lot as you grow up. And this is probably going to be a very large source of jobs and money and things like that. So definitely a really important idea to know about. All right, so we've talked about work and power. We've talked about the idea that work is done when a force is applied to an object and the object moves in the direction of that force. Formula for that is work equals force times distance. And again, like I said before, think about that in terms of not just a mathematical equation, but the fact that it kind of makes sense. Like I said, if you have to push something really heavy and you have to push really hard on it and you have to push it a really long distance, I think you would say you've done a lot of work. And so that idea should make some intuitive sense to you, along with mathematical sense. Power is the amount of force in an amount of time. So this is the idea that if you do work faster, that you are more powerful. And the equation there is power equals work divided by time. And that's it. We'll learn some more about this and do experiments with this in class, and I'll see you then.